turn on the bottom button, hold it down for a little bit, then release. Got it. Okay. Do the slideshow from the current slide. Well, okay, here we go. While that's coming up, the projection's coming up, we are recording. Let me just talk about the rest of the term, which is not much left. Okay? Last day of class, I know you've been dreading it all term, but it's today. So, sorry, it's going to be over with classes. Okay, now, the final is scheduled for next Tuesday morning, 8 to 9:50. You got an hour and 50 minutes on the final. Right now, the final is shaping up to be 4 questions on Chapter 1, 4 questions on Chapter 2, and 2 questions on what we cover in Chapter 3. So that's what to expect, okay? So it's going to be fairly short, like the last test. I'm going to keep it down to 10 questions so you can finish it sometime in the next week, okay? Now, as I sort of indicated by that snide comment, if you do need more time, you certainly can have it, but I don't think you will, but if you do, but I've got to have it in by Thursday of next week, because Friday I'm out of town. We're driving to New Orleans. I've got a meeting down there. So I will not be here Friday. Grades are due Monday. So therefore, there's not going to be much time to do it, so I have to have everything in by Thursday. And I'm here Thursday until 8 o'clock in the evening, so anything.
Give us any hints on what to study.
Yeah, look at your first test, your second test, and what we do code for our class. All right. Now, it's not going to be the same questions, I guarantee that, but there'll be similar type things you've seen on your quizzes, your tests, and your homework exercises, which you've done so many of. It'll be like those. Only not blank. Okay, never mind. Okay. Now, I forgot to get to the correct. Let me see. I should have done something better here. We started, and we're all up to example 3. So we've already done the first several here. Graphs of exponential functions. We did example 2. And obviously they don't have example 3 listed here. So let's go back to 2. Okay, and let's work 3 here. Next, any other questions? There's a good question about what to study for. If I answered that adequately. And any other questions before we get going? All right. If not, let me get my pen activated here. Okay. Example 3. Oh, okay. For the, in the same coordinate plane, you know what I think I'm going to do? Yeah, it's so hard to do. I'll just draw the plane. Okay, here's the coordinate plane. Okay, I'll tick on a few points here. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, and 8. Up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. In the same coordinate plane, sketch the graph of each function. The first of these is going to be capital F of x, and that's going to be 2 to the minus x. Okay? The second of the, well, let's go on and do that one. How do you graph a function such as that? If you've not noticed it already, the test bank for this text loves graphing. Have you had a quiz or a test that you haven't had at least one graph on? The answer is no. So, know how to graph. Okay? How would you do this? Set up to graph a function such as that. F of x equal 2 to the minus x. It's not a technical. A T-chart, okay. All right, so let's do a T-chart for this one. X, alpha of x. And alpha of x is 2 to the minus x. This will be our y, by the way. Okay. Give me an x. 0. 2 to the minus 0 is?
Oh, to the minus 0. I thought it was 2 minus. It's 2 to the minus. I got you. I'm sorry.
Okay. As in we're doing exponential functions? Okay, never mind.
Negative
1. Anything to the 0th, even minus 0, is still okay. Okay. Give me another x. I feel like a cheerleader here. 1. 1/2. Excellent. Everybody can chip in, okay? Another x. Negative 1. 2. Okay. Yeah. 2 to the negative of a negative 1 is 2 to the 1. 2 to the 1 is 2, right? Okay. Give me another x. 2. 1/4. Give me another x. Negative 2. 4. Very good. Okay. We'll do let's do at least one more here. Negative 3. 8. Okay, negative 4 would be 16. I don't think we can go that high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. I think that's about all we can do there. So let's plot those. How do I plot the first one? 0, 1. Second, go up 1, right? Just don't say yours. Okay. Next. Right 1, no, right 1, up 1/2. Okay. Next. Left 1, up 2. Next. Right 2, up 1/4. See why I quit putting those in? Next. Left 2, up 4. Right about there. Left, whoa, yeah. Left 3, up 8. 5, 6, 7, 8. Who do we appreciate? Okay, there we go. And the next one, 4, would be 16, which is off scale. So you see what this one looks like. It's getting closer and closer. I didn't quite get on the money down there, but got the general idea. Okay. Now, pick a color other than black. Dark or light? Light. Okay. We will do g of x now. G of x is equal to 4 to the minus x. How do we want to do that? T-chart. X, 4 to the minus x. Give me an x. 0. 1. 1. 1/4. Excellent. Okay. Negative 1. 4. 2. 1/16. Negative 2. 16, already off scale. Okay? So help me plot those. Up 1. Okay? 0, 1. Next. 1, 1/4. That other graph should have been up there. There's where that one is. Next. And up 4. Next. Right 2 and up 1/16. Somewhere in there. Okay? Left 2 and 16 off scale. So here's what this one looks like. Okay? Now, the left here, it's way higher than first one. But on the right, it's below it. So it crosses at, and guess what? They all cross at 1. Okay? All right. Okay. Yeah, I do. Let me, excuse me just a minute. Okay, it's going to take some digging. By the way, if you want your first test, there it is. And here's test 2. Okay. That's the differential equations. And test 1 in your algebra. Test 2 in linear algebra. You just turned in test 3, didn't you? Yeah. Okay. Here is your last page of test 3. It looks like a lot, but I think you'll find it pretty easy. The first page went through 9. That's the second page. Okay. That's it. You've gotten in both all papers, right? Okay. Thursday of next week. Sooner the better, but Thursday's the very latest because I'm not on campus Friday. We're going to New Orleans, and great to be on Monday. So I've got to have them by Thursday. Okay. All right. Sorry about that delay. Here we have what it looks like. The higher the base, since you have a negative exponent, the large numbers are to the left, small numbers to the right. Everything goes through 0, 1. And that's where they cross. Okay? And the higher numbers go up faster here, decrease faster here. Smaller base is slower to increase, but slower to decrease as well. Okay? Make sense? If you look in your text, I think you'll see their picture almost as pretty as mine. They didn't use 2 colors. Should have, shouldn't they? Okay. Any questions? Example 3. Now, that leads to, now they do their t-tables horizontally. I like to do a lot of things horizontally, but t-tables is not one of them. Okay. Anyway, you can do it however you want to. Here is the general information. Following summarizes the basic characteristics of your exponential functions. Either y is equal to a to the x, or y is equal to a to the minus x. Remember, a cannot be what? 3 things it can't be. It can't be 0. It can't be negative. It can't be 1. It cannot be 1. Okay? 1 would just be the number. Okay. All right. So, if you, for all a's greater than 1, then this is what we have. Okay? The graph of a to the x for a's greater than 1, domain, all real numbers. Exponential functions are always all real numbers. Okay, the range, yes, but not counting 0. Open to it at 0, never reaches 0. Approaches it, over here, approaches it, but never reaches 0. So always greater than 0, going to infinity. And it goes there really fast on whichever side is the positive side, is the greater side. This one is always an increasing function. Always. Now, if a function's always increasing, what's another characteristic of it? That's a one-to-one function. Very good. Okay, you wouldn't do good on. You were a punter. How could you get the signal? Never mind. All right. Yeah, just kick it. Okay. I don't have any colored boards, sorry. Okay. Increasing function, which means it's a one-to-one function. If it's a one-to-one function, what does that mean it's got? You're the one not very good at charades. I am really good at it. Never mind. It's an inverse function. If it is one-to-one, it has an inverse. And by the way, I did see Sean come in, but I was in the middle of something, then I forgot to come back and mark you. So let me get you here if I can find you. I know you're in here. Don't hide. There you are. Okay. All right. And since need to take a quick break here, let me get Sean her papers. Have you finished everything?
I got to do test too.
Okay. You want to work on it now?
Yeah.
Okay. I'll get you the other two papers later, okay?
Okay.
Right in the middle of class. Okay, do you need graph paper?
Yes.
Okay, got this. And here's, okay, you can go next door if you want to. It's quieter, that's where others are taking. Okay. Okay. All right. Increasing function tells you, strictly increasing tells you two other things. Number one, it's a one-to-one function. Number two, it has an inverse. We'll get there later. X, what about its x-intercept? Doesn't have one. How about y-intercept? 0, 1, exactly. That makes the x-axis a horizontal asymptote only in the negative direction, not in the positive. The positive increases without bound. Okay? So it's a one-sided horizontal asymptote. Is there a vertical asymptote? No, because it just keeps increasing without bound. And since the domain is all real numbers, it just keeps going. No vertical asymptote. It's also continuous. Okay? Not only continuous, it's smooth. Okay? No angles, no cusp. It's smooth. Okay? Later when you get to calculus, that tells you something else. It's differential. We're not there yet. Okay. Now, what if it's a to the minus x? Again, a being greater than 1. A can't be equal to 1, so greater than 1. Well, guess what the domain is? All real numbers. Exponentials always are. How about its range?
Approaching 0.
Okay, from 0 up, but not counting 0. Okay? Y-intercept? 0, 1. X-intercept? Not 1. Okay? It's always a strictly decreasing function, meaning it's also 1-to-1, which means it has an inverse, exactly. Okay? Does it have a vertical asymptote? How about the horizontal asymptote? Yes, y equals 0 in the positive direction. The x-axis is that. And it's also a continuous and what else? Smooth function. Notice the graph of the exponential function is always either increasing if, okay, there's two cases here. They only gave one of them, okay? So this might be a little confusing to think about. But let's go back here, okay? If this a, remember a can't be, it can't be negative, it can't be 0, and it can't be 1. We only did for positive a's. If we went for a's between 0 and 1, it can't be either of those, but any a between 0 and 1, guess what it's going to look like? That one, okay? And if you did this function with a's between 0 and 1, it's going to look like that one, okay? It just flip-flops, okay? And, I mean, they look identical, okay? but that's why it can't be 0 and it can't be 1. A to the 0, 0 to the x is always 0. Not very interesting. 1 to the x is always 1. Not very interesting. Okay? But if you'll think about it, if this is a greater than 1 doing like this, but as they get closer and closer to 1, it's less deep, but it still does this. Equal 1, it would be flat. Less than 1, and just slightly less than 1, I'm sorry, went the wrong way, it would be coming down like this, and then steeper and steeper. So you see, A equal 1 would be the flat line there, meaning it's dead. No, I'm sorry. That's not what it means. Okay. All right. As a result, these graphs pass the horizontal line test, which means they are 1-to-1. That's exactly what that means. Because they're strictly increasing or strictly decreasing past the horizontal line test, they are 1-to-1 functions. Because they're 1-to-1 functions, they always have an inverse. Very good. Okay. Now, because they're 1-to-1, now we're going for all a's greater than 0. It never can be negative, can't be 0, and not equal to 1. If a to the x is equal to a to the y, that's true only if x is equal to y. Right? Because they're 1-to-1 functions. If this output value is the same as that output value, because they're 1-to-1 functions, the input values have to be equal. 1-to-1 property. Okay. Let's do example 4 because they're skipping 4, 5, 4, and 5. So let's do 4 and 5. I think this might be the best slide to do them on. Yeah, let's do them on this slide. Example 4a. 9. Why did this go back to that? Oh, I know. You had me change colors. Okay. 9, your fault, okay, is equal to 3 to the x plus 1. There's an equation. Can any of you solve that equation?
You have to flip.
Okay. Flip it out. Okay.
I don't remember how to do it.
Say again?
I thought you said Google Ads. I think that's what it is.
3x plus 3x plus 9. Just flip them around.
How? You mean just switch sides of the equation? I can do that, yeah. No problem there. 3 to the x plus 1 is equal to 9. Does that solve it for you? Okay.
Divide by 3 on each side.
Take the square root of both sides.
Okay. It says as it's squared, so square roots don't really help you. However, you're really thinking in the right direction. Okay. Remember what we just said, the 1-to-1 property? If you can get the same basis, then you can set the...
Multiply that one by 3.
Okay.
You would divide by
It's very close to what you were saying. Can you write 9 as something with 3 as its base?
you taking this
3 to the 3rd power.
Oh, boy.
3 to the 2nd.
Second power, all right. Okay. Yes, we have 3 to the x plus 1 is equal to 3 squared. All right. Another time out for just a moment here. Let me get stuff to Amari. I'm sorry. Oh, that's right. Jared, right. No, I mean, you got something. You've been here for...
So you turned in and
Oh, I think it's... Okay. I forgot to give Shun her stuff. Okay. Diana, Kamari, Jared. There's your first quiz. Okay. Kamari, Jared. You said you hadn't finished the first test. Are you going to finish it? Huh? You would? Okay. There's next door working on it, so take it next door. Okay. Did you turn in the second quiz? Okay, well, you take it next door and work on it too. When you finish and turn that in, you can do test 2. Right next door. 257. You can either go through there or around. But if you go out in the hall, don't close the door because it's locked from the outside. I don't have to keep it that way. I can open it from the inside. Okay? And let me mark you present too. And Jared's here. All right. All right. Now that we have the same basis, can you solve that equation?
Wait, would you ask?
Now that you have the same basis, can you solve that equation?
Yes.
How?
You have.
You set your exponents equal to each other. If they're the same basis, they're one-to-one functions, then the exponents have to be the same. If these two things are equal, that means x plus 1 is equal to 2. And x is equal to 1. Subtract 1 from both sides. Yes, you can do that. And it wasn't that hard, was it? All right. Let's do the B one. 1/2 to the x power is equal to 8.
It's always the 1 power.
What's that?
X equals 1. Oh, never mind. You have to give us. You have to put it, 16. Multiply by 16.
Okay. I think I understood what you said. You have 1/2 to the x power is equal to 1/2 to the -3 power. Because that would be 2 to the 3rd power if you flip it. Okay. And that would be 8. So now can you solve that? X equal -3. Okay, do this.
That one's also.
Yeah. Okay.
Could you not multiply that one to make it 8? Could you do that if you wanted to?
Say that again.
Could you make that one 8?
Make what 8?
Multiply 1/2 times 16 over 1 and make it 16 over
Okay.
2.
Okay, 1/2 is being raised to a power. You can't just,
So if you ever want a fraction, you just
yeah, you can only multiply. Yeah. Here's what I think you're saying. Okay? Here's what you can do. I'll show it 2 different ways. This is also 1 to the x over 2 to the x, right? Well, you know what 1 to the x is. 1. To whatever power you raise it to. So that's just 1 over 2 to the x, right? Ooh, didn't take. Okay. Okay. And that's equal to 8. All right. Now that still doesn't help you a lot. But now what you can do is flip. And that would be 2 to the x is equal to 1 over 8. Does that help? Okay. What's that?
Base is still not the same.
Okay. But, okay, let's write, this is 1 over, is 8 got a base of 2. It's 2 to the 3rd. Okay? So then you could write that as 2 to the minus 3, right? If you change the sign of here, you can move it upstairs, right? And now 2 to the x is equal to the minus 3, right? So x has to equal negative 3, just like before. Now here's the other way you could have done that if you didn't want to do it that way, okay? You could write this as 2 to the third, okay? Now that has a 2 in the numerator, so if you move that downstairs, it'd be 1 over 2 to the negative 3. And now take this to be 1 over 2 to the x, and now again you've got x equal negative 3. There's several paths you can take to get there, but you've got to get same expression on one side as the other, just the exponent's different. And then you can set them equal to each other. If that's an equality, it's got to be true. That's the what they call the one-to-one property. Now, let's clear that. Any questions on that before I clear it? Okay, I'm glad y'all are here, and I hope the other folks are listening on Screencast-O-Matic, because something from this is going to be on the test, right? At least 2 questions. Okay. Now, transformations of graphs of exponential functions. Each of the following graphs is a transformation of the graph of f of x. And if you haven't noticed, this book, this test bank, loves these transformations. You've seen them just about every quiz, every test. Maybe not the first quiz, but all the rest of them. Okay? F of x is equal to 3 to the x. Okay? Now, what would g of x, which is 3 to the x plus 1, be? Okay, you're not setting them equal to each other. Okay. I want you to describe to me what the graph, we know what the graph of f of x would be, right? It would go through 0, 1, 1, 3, 2, 9, 3, 27, yeah. That's what that one would look like. Something like that, right? My question now is, what does that one look like? SA, what kind of shift? Horizontal shift. Good guess. Okay. In which direction? Left. Okay, very good. You want this in bright red again? Okay. Shift that to the left, this to the left, that to the left, and here's what this one is. Because now it's not going through there because it's not to the single power. So that's exactly what that one is. If you look in your book, you can see that's what g of x is. All right? Now, h of x, what color you want that to be? Blue. Blue. Light or dark? Dark. Okay? H of x, I think it's a llama or a weed eater or something like that. H of x is equal to 3 to the x minus 2. What are we going to do to our parent function, the black function, f of x? So
It's gonna be down 2, because that's the y value.
yes, it is. A vertical shift downward by 2. So this will go down 2, 1, 2. This will go down 2. It'll be somewhere like here. And this will be down 2. It'll be something like there. And these will be down, so something like that.
Can I ask you a question?
Yes.
What happened, like, what makes it flip?
No, you asked the question already. I said yes. Okay, go ahead. No, go ahead.
What makes the whole entire thing flip?
Even if it was a negative.
If you put a negative in front, negative 3 to the x.
Okay, what makes it flip over the y-axis?
3 to the negative x. Negate the function, and you negate it that way, negate the x, and it flips it that way. Yeah. Very good. Excellent question. Okay. Now, remember I said exponentials always go through 0, 1. That's unless they've got a shift involved with them, like a horizontal shift or a vertical shift. That is going to move where it crosses the y-axis, of course. Okay? Let's look at k of x. What color you want it? Green. Light or dark? Dark. Okay? K of x is equal to, you were psychotic. I mean, psychic. Yeah. Psychic. Okay? Minus 3 to the x. What would that be? It would be a reflection which way? Across the x-axis. So you take this one here, reflect it down here, but then that would be, so I didn't leave enough room for this, but it's heading down that way. Exactly this flat one. What were you saying? Okay. Notice that's not negative 3 to the x. That would have to be like that. We don't do that, remember? You can't have your base be negative. This is negative 3 to the x. Rule of order of operation, exponents before subtractions. Negation.
So if it was in the parentheses, what would it be?
You can't do it because you cannot have the base being negative. Because if you just think about that, if you just left the x to be whole numbers, if it was a negative base and x was a 1, that would be a minus. Okay? If it's 2, it would be a plus. If it's a 3, it would be minus. Yeah. That would be nuts. Wouldn't be a function. Okay? And now D. What color you want this one? Light purple. Okay. I thought you said white purple. I don't know that one. Okay. My hearing's not good. Okay. J of x is equal to 3 to the negative x across the y-axis. So it's going to go through there, and then it'll go through here, then it'll go through here, it'll go down here. So here's how that looks. Just exactly a mirror image across the y-axis of your black function. See it? They love these transformations, folks, don't they? They have a checkpoint, too, so you can go home or go to the library and work on some of those. All right, now we're ready for the natural base E. Have y'all run into that before? These are called exponential functions with the base E. Does anyone know what the base E is? It's 2.7 something. That's it right there. In many applications, the most convenient choice for a base is an irrational number. It seems like that makes no sense at all. The reason we call it the natural base E, it is the natural base of our number system. We say we're base 10, that's just for arithmetic. But when you get to the real meaty parts, this is the natural base. It's an irrational number. Now, it looks like it's repeating this segment. It's not. It keeps changing from there on. It looks like that group of numbers is repeating. It's not. If anyone's got a calculator with more digits than this, do e to the 1. See what you get. Oh, it knows it has it's the same number. Okay. But it probably the one I have on my, no, I don't even know if that'll work. Okay. Anyway, this number is called the natural base. The function f of x equal to e to the x is called the natural exponential functions. All the rest of them are exponential functions, but with fixed bases. This is the one with the base e.
I got it.
You got it? How many digits you got?
2.718, 2818, 2845945.
See, you don't repeat those anymore. Right. So very good. It's not a rational number that repeats that. It just happens to be those 4 digits repeated once, but they don't repeat after that. So, how do you think it graphs? 0, 1 is always there, unless you have a transformation. But then when you get up here at 1, it's going to be E, which is 2.7 or so. So it's somewhere up in there. And this would be 1 over 2.7, which would be almost 1/3, not a little past 1/3. This would be a little past 1/9. This would be short of 9. So you see, it's shaped just like the others, only it's in between 1 over 2 to the x and 3 to the x, closer to 3 to the x. That's what it looks like. All right. Be sure that you see for the exponential function f of x equal e to the x, e is a constant. It's not a variable, but we also treat it as if it's a function. So that's a little weird. Whereas x is the variable. Okay, there's the variable. That's the constant. Okay. Now, example 6. You'll need a calculator for this. Hint, hint. On your final, bring your calculators. You may have to actually do a calculation, which you do on the other parts too. Use a calculator to evaluate the function f of x equal e to the x at each of these values. So you want to go back to black? I do. Okay. Now, what would be e to the minus 2? I know it's going to be 0 point because it's going to be less than 1, right? You can do it. I bet you.
It didn't do it.
Okay, let me see what you do.
It's the negative.
Find your E.
It's 0.1355.
Oh, you're talking about like down here.
I got it.
You got that. I thought you were talking about
Okay,
No.
no. Okay. That was 0 point, what'd you say?
0.135335.
Okay, blah, blah, blah. Okay. So there's e to the minus 2. How about e to the minus 1? Blah, blah, blah. All right? What do we say before? It's a little bit more than 1/3. 1/3 would be 0.33333. This is 0.337. Blah, 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 blah. How about e to the 0.25?
1.284.
So again, 1.284. Okay? Blah, blah, blah. Just a little bit more than 1 because you're just going a quarter past 1, so it's 1.2. That makes sense. How about negative 0.3? E to the negative 0.3 is what?
0.7408.
Okay. Blah, 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 blah. Whoa. Now, does that make sense too? Well, you saw that e to the minus 2 was a pretty small number. E to the minus 1 is less than 1, but bigger. E to the minus 0.3, you're getting closer to e to the 0, which would be 1. So sure enough, this is getting closer to 1. But still less than 1. Okay? Does that make sense? So you know how to calculate your e's. Okay. I think I need to erase this. So let me just see. All right. Oh, I didn't. They were going to do it. In your calculator, you press the e to the x. Now, different calculators have different protocols. So you have to know your own calculator. If you have a scientific calculator, yeah, it does just about the same thing. Well, no, the minus is a little different. So if you don't know how to get these, ask me after class and we'll try to figure it out. Or right now, I'll try to figure it out. So that was your e to the negative 2 would be your e to the x key. And some of those, that's on a second function. Okay? Do you not see how to do yours, or? You okay? Okay. All right. And on these, you will need at least a scientific. The little cheapies aren't going to do these for you.
Your phone does it.
Huh?
If you have an iPhone, it does it.
It does. Okay. All right.
Look, on the 2, you have to go press 2 and then press the change sign and then press e to the x.
You got a calculator to do it? Good deal. Okay. And e to the minus 1. Enter it the same way, 0.36.
Hold on. She didn't have the. Oh, this. So 2.
So, yeah, now you can do lots of things, anything you do with scientific calculator. The first one that pops up is just your simple calculator, but then whatever he told you to do. Yeah. All right, make sense? Then alpha, the 0.25, it's greater than 1, so it's going to be, greater than 0, so the answer is going to be greater than 1. And then something slightly less than 0 is going to be closer to 0, but still less than 1. Make sense? Get them all? All right. Now, they're skipping example 7. Don't know. Whoa. Okay, let's do example 7 here. Sketch the graph of each of the natural exponential functions. Okay? Now, first thing I look to see if there's a minus in front of the whole thing. There's not, so I know I can put it down here because never going to reach 0. Come close, but never reach it. And the first we're going to do is f of x is equal to 2e to the 0.24x. 2e to the 0.24x. Okay? What would you do? Okay. I think what you're doing, you're plotting as you go, aren't you? You're not setting up a t-table, t-chart, whatever you want to call it. I'm going to choose an easy one. I won't need a calculator. X equal 0. What would that give you?
It looks like that.
Thank you. What would x equals 0 give you? Here's your function. What happens when x equals 0? What do you get?
That 0, so it'd be 0.
Okay.
Anything to the 0 power is 1.
Except you got something to the 0th power, 1 multiplied by 2. That would be 2. That's a vertical stretch. Okay? So 0 is 2. All right? How about at 1? 2 times e to the 0.24. Say 2.54, is that what you said? 2.54, that'd be something about like there.
At 2, it's 3.
At 2, it's 3 on the nose, or pretty close?
It's pretty close to 3.
Okay, pretty close to 3. At 3, it's 4.1. Okay. At 4, point what? 5.2. Okay.
And
Negative 1, it would be 1.5. Okay. 1.23. Generally, you get the idea it's doing like this. It's a pretty slow progress because you have a pretty small coefficient for the x.
After the 4th one on the side, it just takes off.
It does, right.
It goes up to like
5.
6, it's like
Huh?
8.
8, yeah.
It goes to the,
All righty. Now, let's do it on the same graph. What color you want it? Say again? Purple? Light or dark? Dark. Deep purple, that was a good band. Okay. Never mind. Okay. This is g of x. So deep you can hardly tell it from the black, can you? Is equal to 1/2 e to the negative 0.58x. Test 2, good. No graph? Okay. All right.
It rises on the left and falls on the right.
Okay, absolutely. That's because you have a negative exponent. So give me a few values.
It reaches
What's it going to be at 0?
0.
No, it's not.
It is.
X equals 0. Negative 0.5.
The y-axis, it crosses at the origin.
No, it doesn't. Expand your scale. Look at it.
And which one?
X equals
I'm
0.
trying to trace it.
X equals 0. 0.58 times 0 is 0. Negative 58 times 0 is 0. E to the 0 is? Anything to the 0th power is?
Oh.
1.
I forgot to press the trace button. I'm sorry.
Okay.
It's 0.5.
0.5, exactly. 1/2. Okay? So this will be down there at 1/2. Okay? Good deal. What is that? Quiz 2. Okay. Do you need your test 2?
Can I come to your office tomorrow and do it?
Okay.
Or
yeah.
later today?
Yeah.
I have a class right after this.
Okay. All right. Well, I'll be here today until 8 o'clock. Tomorrow I'll be on the Birmingham campus. You want to come there and do it?
I'll do it here later today.
Later today.
Yes.
Okay. Now, I'm in the office between 12:15 and 3:15, and then I'm up here in class after that. Yeah. Until 7:45. Okay. Okay. Well, catch me before 3:15. Or come up here after 3:15. Okay. That's 2. No graph? Okay. All right. All right. So let's plot me some more points. I've got 0, 1/2,
At -1 is 1.
-1, 1, approximately.
It's like 0.9.
Yeah, okay.
At -2, it's 1.5.
1.5, something about like, get out of there. -2, 1.5.
It's 2.8.
Whoa, I went too high. Okay, sorry about that. Let me erase that one. Okay. Say again?
At -3, it's 2.8.
2.8, something about like there. Give me one on the positive side.
At 1, it's 0.279.
0.279, somewhere down there. Okay? So basically it's going something like this. Okay? Now, notice again you have a vertical shrink and you have a horizontal stretch. Okay? On that one, same thing, horizontal stretch with a vertical stretch on that one. So you see that's what's going on. Okay. I think, therefore I am, that we must be out of time. Okay. Does anyone else need a copy of these scholarships that due dates are in December?
I'll give it back to you.
Okay. What's that? Okay. If you finish with them, want to get them back to me, I only have a limited number of copies. Yes, sir. I'm sorry. Okay, you can, but I got to grade what comes across. So if the format gets screwed up in the emailing, I got to grade what you get me.
I have all the programs, so like, as long as I send it in Word, PDF, or something like that.
Okay, I mean, I grade what comes across. Whatever you do, I grade what comes across.
I'm sure it'll be ready.
Okay. Most of the time they are, but I've gotten some screwy ones. And it may be the screwy ones were because they were screwy when they sent them. If they had printed them, they say, hey, my format's all screwed up, you know. So,
I already know.
yeah, okay.
You said you wanted the first quiz back?
No. I graded it, right? I will record it right. Okay.
I didn't write the date on this one, 'cause everybody did.
What's this, quiz 2?
Yes, sir, this
Is that all you're going to do? I mean, it's up to you. I'm asking you a question.
I want to finish it, I just didn't recall it.
Well, it's an open book. The quiz is open book. The test is not.
Yes, sir.
What is that? Is that test 1?
Test one.
Are you finished it?
Yes, sir.
You are? Grade this. Okay. So mark out the knot, right?
Yes, sir.
Okay. And when are you going to do test 2? That's your quiz.
So,
I was one of those papers that was this, right?
I don't need it.
Okay.
Where you gonna be at like 10?
At when?
10.
10 tonight? Oh, what did you say?
Like where you gonna be at? Like you gonna be in your office or you gonna be in here? 'Cause I'm gonna
This
bring
morning
my-
at 10?
Yeah.
I'll be teaching a class here.
Okay, I'm gonna bring my paper.
Okay, great. Thank you.
you.
Got it. Okay. All right, thanks.
Y'all took test 2 on Tuesday.
What's that?
Y'all took test 2 on Tuesday.
Yeah,
I'd like to do it today. or-
today I'd like for you to do it. Today when?
When's a good time? Around 12?
Okay, I'll be in class at 12. I get out of class at 12:15.
I'm just trying to figure out a free good time for you.
I get out of class at 12:15. I'm out of class until 3:15. So those are my office hours
So
today.
around 12:15.
That'll be fine. I may still be up here at 12:15, but yeah, you can catch me here or catch me down in my office.
Listen, thank you.
Okay.